Lesson: Data pipelines for AI applications. Data pipelines are integral to AI applications, serving as the backbone for processing and managing data flows in a robust and scalable manner. In AI system architecture and design, data pipelines are essential for transforming raw data into actionable insights, enabling efficient model training, deployment, and maintenance. The need for an efficient data pipeline is underscored by the increasing volume, velocity, and variety of data, which necessitates advanced techniques for data handling and processing. A well-designed data pipeline not only streamlines data processing, but also enhances the overall performance of AI systems, leading to more accurate predictions and insights. To build an effective data pipeline for AI applications, one must consider several key components: data ingestion, data transformation, data validation, and data storage. Data ingestion involves collecting data from various sources, which can be structured, semi-structured, or unstructured. Tools like Apache Kafka and AWS Kinesis are commonly used for real-time data ingestion, offering scalability and fault tolerance. These tools facilitate the continuous collection and integration of data streams, allowing AI systems to remain updated with the latest information. Once data is ingested, it must be transformed into a format suitable for analysis. This involves cleaning the data, handling missing values, and converting it into a consistent structure. Data transformation is often performed using frameworks like Apache Spark or Google Cloud Dataflow, which provide powerful data processing capabilities and support for large-scale data transformations. These frameworks allow for distributed processing, enabling users to leverage multiple machines to process large datasets efficiently. Additionally, they support various programming languages, making them accessible to a broad range of developers and data scientists. Data validation is a critical step in the pipeline, ensuring the integrity and quality of the data before it is used for model training. Validation checks may include schema validation, anomaly detection, and data completeness checks. Tools like Great Expectations offer a flexible and extensible framework for validating, documenting, and profiling data. By defining expectations about the data, Great Expectations automatically tests datasets and generates documentation, helping teams maintain high data quality standards. After validation, data must be stored in a way that supports efficient retrieval and analysis. Data storage solutions vary based on the type of data and access patterns. For large-scale AI applications, distributed storage systems like Hadoop Distributed File System and cloud-based solutions like Amazon S3 or Google Cloud Storage are popular choices. These systems provide scalable and durable storage, capable of handling petabytes of data. They also offer integration with various data processing and analytics tools, facilitating seamless data flows within the pipeline. In constructing data pipelines, orchestration and automation are crucial for ensuring smooth and reliable operations. Workflow orchestration tools like Apache Airflow and Prefect help automate complex workflows, providing scheduling, monitoring, and error handling capabilities. These tools enable users to define pipelines as directed acyclic graphs, allowing for clear visualization and management of data workflows. By automating repetitive tasks and handling failures gracefully, orchestration tools significantly reduce manual intervention and operational overhead. One of the real-world challenges in building data pipelines for AI applications is handling data consistency and quality across diverse sources. Inconsistent data can lead to erroneous model predictions, affecting business decisions and outcomes. To address this, companies like Airbnb have developed custom data quality frameworks that integrate with their data pipelines, ensuring high data integrity and reliability. By investing in data quality tools and practices, organizations can enhance the performance and trustworthiness of their AI applications. Another challenge is optimizing pipeline performance to meet the demands of real-time AI applications. The need for low-latency data processing has led to the adoption of stream processing frameworks like Apache Flink and Apache Storm, which offer real-time processing capabilities. These frameworks are designed to handle continuous data streams, enabling AI systems to react to changes in the data instantaneously. By leveraging stream processing, organizations can build responsive AI applications that deliver timely insights and predictions. In addition to technical challenges, data privacy and compliance are critical considerations in pipeline design. With regulations like GDPR and CCPA, organizations must ensure that their data pipelines comply with legal requirements regarding data protection and user privacy. This involves implementing measures like data anonymization, encryption, and access controls to safeguard sensitive information. Tools like Apache Ranger and AWS Identity and Access Management provide robust security features for managing data access and permissions, ensuring compliance with regulatory standards. To illustrate the effectiveness of data pipelines in AI applications, consider the case study of a leading e-commerce company that implemented a real-time recommendation system. By leveraging Apache Kafka for data ingestion, Apache Spark for data transformation, and Apache Flink for stream processing, the company built a data pipeline capable of processing millions of user interactions per second. This pipeline enabled the company to deliver personalized recommendations to users in real time, significantly enhancing customer engagement and sales. The success of this system underscores the importance of a well-designed data pipeline in driving business value from AI applications. In conclusion, data pipelines are a fundamental component of AI system architecture and design, playing a critical role in data processing and management. By employing practical tools and frameworks, professionals can build efficient and scalable pipelines that meet the needs of modern AI applications. Key considerations include data ingestion, transformation, validation, storage, orchestration, and security, each of which contributes to the overall performance and reliability of the pipeline. By addressing real-world challenges and leveraging best practices, organizations can enhance their proficiency in this domain, ultimately driving more accurate and actionable insights from their AI systems.